plane traveling with the wind travels 1,100 miles in 5 hours. The return trip is against the wind and takes 11 hours. Find the rate of the plane in still air and the rate of the wind. So in a problem like this, we need to remember that we're using this formula, distance equals rate times time. I call it DIRT, by the way. So we have two cases. We're traveling with the wind and against the wind. So I'm going to travel with the wind in this trip, and then we're going to turn around and come back and travel against the wind. So what does all this mean? I need a distance, a rate, and a time for each of these trips. So it says a plane traveling with the wind travels 1,100 miles. So I have a distance, a rate, and a time. We know this is 1,100 miles. And it takes 5 hours. The return trip is against the wind and takes 11 hours. That's pretty much all it gives us, right? Well, if we make the same trip coming back as we made going over there, isn't the distance still 1,100 miles? We're trying to find what the rate is in each of these cases. So how can I find the rate? This one means distance equals rate 1. I'm going to call it rate 1 times time. And this means distance equals rate times that's supposed to be 5 hours. And this one's going to be 11 hours. So how does this help us at all? What does R actually mean in this case? We're looking for two different rates, right? One of these is with the wind. If you're going with the wind, it's pushing you. So the wind speed and the plane speed are going to be added together because they are working together. So the rate is going to be, let's let P equal the rate of the plane. And let's let W equal the rate of the wind. So here, they're added together because the wind is pushing the plane. But what's happening whenever he turns around and comes back? Hopefully the plane is flying faster than the wind. Otherwise, the wind will be pushing the plane backwards. So we're going to have the plane minus the speed of the wind. So now instead of these R's, we're going to put these expressions. So we're going to have 1,100 is equal to rate times time. 1,100 is equal to rate times time. Now we have a system of equations that we need to solve. There's a couple of ways you can do this, but let's just go ahead and distribute the 5 and distribute the W. I'm sorry, distribute the 11. So we have 1,100 is equal to 5P plus 5W, and 1,100 is equal to 11P minus 11W. We need to solve this system of equations. I think I'm going to use the elimination property, so I'm going to multiply this equation by 11. I'll multiply this equation by 5. So we have 1,100 times 11, and we get 12,100 is equal to 55P plus 55W. This one would give us 5,500 is equal to 55P minus 55W. So now we can add these together and the W's will cancel each other out. We add the 12,100 and the 5,500. We end up with 17,600 is equal to 110P. Divide both sides by 110. We end up with P is equal to 160. Well, now that we know what P is, we can find W. We can go back to one of the original equations or one of these equations. It doesn't matter. I'll just go back to the original. So 1100 is equal to 160 plus W times 5. So we can divide both sides by 5. We end up with 220. Subtract 160 from both sides, and we get 60 equals W. So what does all of this tell us? It tells us that the plane is traveling at, these were in miles and hours, yes, they're traveling at 160 miles per hour, and the wind is blowing at 60 miles per hour.